students, and welcome to Solving Systems of Inequalities, which is on page 8 of your notes. So a system of inequalities is two or more inequalities that may intersect. The solution to a system of inequalities is the whole area, the entire thing, where they are both shaded, including solid boundary lines but not dashed ones. A point satisfies a system of inequalities if it's in the double shaded area or is on a solid boundary line. So let's show you what I mean. So a regular system of equations looks like this. The solution is where the two lines cross, and it's a single point, which in this case is 3, 0. So a system of equations has a single solution, and it's just a point. Now here's a very similar set of equations here, except, well, inequalities in this case. I've changed them to inequalities, so the graph looks kind of different. So notice this one has a solid boundary line. That's that one right there. And this other one has a dashed. So you may want to make that more obvious on your paper, because I know it's kind of hard to see on this printed version. So this dashed line, this one is solid. Oops. So if you can see kind of this first, so ignore that. All this stuff is where y is greater than the rule. The rule is 2x minus 3, which is this right here. And the shaded parts are all the y values that are bigger or above that line. And this, so ignore that. So all this right here, that's where this equation is less than. So where the y's are less than that equation, right here. And then we have this area, which got shaded by both inequalities. So this part right here, and it goes on to infinity, keeps going, is the solution to the system of inequalities. So the solution to a system of inequalities is the entire double shaded area, including solid boundaries. So like this part here is included. So all the points on this line are included in the solution. These points are not included in the solution because it's a dashed line. So let's try an example. We're going to solve these by graphing. You can do them algebraically, but we are going to do them by graphing. If you want to see the algebraic way, let me know. You must have your equations in slope-intercept form, which is not actually true anymore. Thanks, Texas Instruments. Solve the system of inequalities below. So, go to a graph page and do menu 3, 2 to graph a relation. Then you can type y plus 3, and then if you press the control equals button, then you can choose from all the inequalities. So we want that one. So it's greater than 4x. Press enter. And oh my gosh, it shades it for you. So let's draw that in. So notice in the calculator, that line doesn't really look all that dashed. I mean, it kind of does, but not that well. So make sure you draw it dashed. And then all these points in this area are the y values that are greater than whatever's on the line right there. So then let's put in the second one. So you can press tab to get a new entry line, and it's going to stay in that relation form. And we want 2x plus y, and then control equals is greater than or equal to 3. So I've added that second inequality to my graph. And you can see all these points are the ones that are greater than or equal to the ones on the line. So this double shaded area right here, including this boundary, that is my solution set. So this right here, this area is my solution set. So that's really all there is to it. Let's try one more. So there's one more example on page 9 right here. Solve the system of inequalities below. So I'm going to go ahead and type that in, and you should do the same, and I will be right back. So here's what your graph should look like. Your solution set is this big ol' area right here, including this line, not including this one. So then number 3, does the origin satisfy the system of inequalities above? So let's look at page 8 again and see what that means. So a point satisfies a system of inequalities if it is in the double shaded area or is on a solid boundary line. We just have to see is the origin, which is 0, 0, in the double shaded or on a solid boundary. So that's what you're looking for, is 0, 0 in the double shaded area of this graph or the solid boundary line. If so, it satisfies the inequalities. Otherwise, it doesn't. So you decide. And yes, it's in the double shaded area. It is right here, which is in the double shaded area. So yes, it does.